Yeah. Hey everyone. Thanks for coming here today. I hope people can see us. I don't know if we are live, but yeah, I'm Rohan Mehta from BlockScience. I am a research engineer at BlockScience, and I want to kind of introduce this call. Like we are hosting this as a part of the governance module library. It's a community call for people who want to be involved in this project or understand governance modules and discussions around it. Um, this project originally came out of the work on Neural Quorum Governance, and this call itself is specifically going to discuss the process of building that whole governance module. And we have like a amazing team that actually was involved in building this. So I would like to acknowledge their hard work through the project, and also Stellar Development Foundation for streaming and co-organizing this event. Um, I guess we could go through the agenda. I guess Arthur, are you? Yeah. So the stuff that we want to cover through the call today is we'll have a brief introduction of the speakers. Maybe I'll just give them a shout out as to what sections they'll cover through the call. So we'll have a presentation of like about 20 to 30 minutes where we'll cover all uh, the building blocks of how we came about through the neural quorum governance, or like how the building blocks are built together. Every section will be discussed by one presentation each, by Anki, Jacob, Danilo, Arthur, and then me. And then we'll move on to the Q&A section. Eventually, yeah, and then we'll discuss maybe if there are any questions that you guys have as a community, please feel free to put up in the YouTube comments. And I think Hash will be involved in uh, discussing with you all on the comment section and also bringing the questions to us. Yeah, so maybe like we can do a quick recap of what governance module library is, which basically we are trying to build a collection of governance modules that are so important in the socio-technical systems that we are building online today. And I really love this enthusiastic community, like in the sense that we are coming together and actually putting these modules that are going to be open source. We are building like the frameworks to uh, come up with the idea, discuss with each other, and building the models or even the discussion threads through which we can understand when to use which modules for which kind of applications. And um, so again, like this is a community project, so whoever wants to join in, feel free to come up to our GitHub, and we'll share those links as we go through the call. I think we can start off with Anki. Maybe she'll go through the strategic goals of the NQG. Jacob is gonna maybe discuss the early designs and the general work at BlockScience that we do in order to understand these governance projects. Danilo will, if he can make it to the call, he'll be discussing on the design and modeling, Arthur on the implementation, and then I'll be covering the reporting and analysis section of how we steer the governance modules while we are building them, and how do we understand whether they're actually going through um, where they're matching the goals that we had expected them to. So maybe Anki, you could take over the next section. Ideally, we shouldn't cross 5 minutes, more than 5 minutes each, and we can leave some time for Q&A at the end. Yeah.
All right, next slide. This is the governance model library. All right. Yeah. Thank you so much, everyone. Thank you so much, Rohan, for that awesome introduction. And it's so great to present here with you all today. My name is Anke Liu. I'm the Ecosystem Growth Lead at the Stellar Development Foundation, which is a nonprofit organization that supports the development and growth of Stellar. And so at the foundation, I lead our ecosystem growth team, which manages the Stellar Community Fund, which is the first use case that has implemented Neural Quorum Governance, or NQG for short. NQG was designed to offer a more sophisticated alternative to token-based governance and have the ability to measure things like reputation, expertise, and trust, rather than simply relying on token holdings. Stellar itself is designed with the mission to create equitable access to the global financial system, which means it's very much real-world impact use case type of focused. And with NQG, we wanted to kind of create a governance system that resonated with that ethos, where someone didn't need to buy their way in or be one of the early adopters or always have the time to contribute. And at the the end of the day, the main goal of any democratic governance system is to get ample and diverse participation for effective decision-making. NQG offers customizable design where members can work their way up, gain trust and reputation in the ecosystem to have more influence in decision-making with flexible options for participation. Therefore, it sets a great framework to solve some of the more common problems that we see often in Web3. Next slide. So like some of the common problems are inaccurate community sentiment, so not representing the entire community. We also see with the representative voting a lot of centralization and collusion issues, especially when bills come in last minute to skew their voting results. There's also a lot of voting fatigue and apathy. Not everyone is necessarily feels accountable to be involved. You see this a lot with direct, like democracy, direct kind of governance, where it's like, oh, I'm just one of the many, my vote doesn't count. We see that a lot as well, or people are just getting tired of looking at different threads, and it's a lot of work for them. We also see a lot of Sybil attacks and manipulation because of the lack of, or at least lack of kind of a proper identification solutions where people try to manipulate the voting results with a number of fake accounts. We also see low information voter problem is a big thing, whereas not everyone needs to vote, and people actually oftentimes need high context to be able to make a really good decision. Often these mechanisms are also not as scalable, or especially when it comes to direct governance or adaptable. Often they stay similar or they get stuck in a particular way because that's how it's been designed. And many more, of course, there's many security issues in DAOs governance as well, and other type of hacks that are happening. And next slide. Most of these governance systems, whether it's Web3 or not, rely on either direct or representative governance. And actually we thought about, well, what if liquid democracy could actually offer the best of both worlds? People can choose both whether they'd like to vote directly or to delegate their votes. And so as voters are able to delegate to experts, it can lead to more informed decision-making. It could also be more inclusive through flexible participation based on the level of availability, expertise, or interest into a particular issue. And as voters can choose to redelegate or in some cases override a delegate's votes, it holds delegates accountable throughout the delegated period, which is one of the most important things when it comes to delegated voting. Despite these benefits, we haven't really seen widespread adoption of liquid democracy mechanisms and the way the other two have. Sophisticated and verifiable systems as well as voter onboarding are required to make it work, and it does take a bit more effort than representative voting. So yeah, and as there's still a lot of great deal of delegate voting involved, it doesn't actually solve all of the problems directly. So next slide. Last year, we collaborated with BlockScience to design a framework that takes after a form of liquid democracy, and it's called Neural Quorum Governance. It combines both modular voting power attribution, which is neural governance, with opt-in delegation of voting power to trusted groups, quorum delegation. As this open source network, anyone can use it to design governance systems that prioritize community alignment, participation, and adaptability. Voters can either vote directly with various amounts of voting power, or have the decision made as a quorum result from a self-selected group of voters that they trust. And this allows also for a buffer to protect against non-voting or rogue voters. And as these quorums are self-selected, they can be altered with each decision and or per topic. It can also avoid potential collusion issues. Next slide. Some of the use cases of neural quorum governance include public goods funding allocation, because NQG has the ability to incorporate evaluating criteria beyond profit potential. Another one is domain-specific expertise representation. NQG allows the community to set neurons for a particular governance action to be higher weighted towards individuals with a particular expertise, for instance. We're also actually exploring category-specific quorum delegation, where actually we have different types of groups of categories of projects, such as financial applications, infrastructure and services, etc., where actually there will be a specific quorum that people can select for each of these categories. There's also adaptive governance, and so as neural governance can accept inputs at each layer, they can actually transform them into weighted outputs for the next layer, which also allows for cross-round adaptations. Next slide. So Neural Quorum Governance has been implemented first in the Stellar Community Fund. It's just a community-powered award program to support projects building on Stellar. Since its implementation in October 2023, the fund has leveraged the pilot version of NQG to allocate over 15 million in XLM to over 300 submissions. Next slide. So I think Archer will go into this a little bit more, but SCF's implementation uses Soroban, which is Stellar's native smart contract platform. And as a community is mainly based on merit and reputation rather than token holdings, our initial choice of neurons included number of users that trusted the voter, voter history, and Discord tiers. It also SCF leverages criteria-based tiers pretty heavily in governance. So some of the ability to vote actively and delegate is reserved for the highest tiers, while the lower tiers are only able to delegate. And this allowed us actually to double our voting count without negative impact on the outcome. Next slide. And lastly, I'll end it with a little bit about kind of our roadmap so far. So we started in early 2023 with kind of the ideation and landscape analysis, which like Jacob will go into a bit more, and then we scoped out the requirements. Archer will go into like the prototype development, and then we implemented kind of like the beta version, like a pilot of NQG into SCF, which we have been testing these past few months. So far, we have been working on kind of simulating and calibration, and like Rohan will go into it a bit more. And we're looking to and we have fully adapted it we have an open source repo right now, and the contract is on mainnet. And our next phase will really be about ecosystem collaboration, where we will try to find more people to collaborate and add features. And so I will definitely say a few things at the end, but I believe that I have already crossed my 5-minute mark by quite a bit. So I'll keep it to this, and yeah, super excited to hear from our next speaker, Jacob.
Thank you so much. I'll start with saying I'm also with BlockScience. I'm Jacob. I'm a technical project manager and researcher. I've been involved with the NQG and now the GML work pretty much since the beginning, primarily coordinating different streams of technical governance, but also econ considerations. Arthur, next slide, please. I'll first dive a little bit into where we're coming from, what our work usually looks like, and why we tackle things the way that we did, and then go into the initial design phases to give a bit of context of where we're coming from. Next, please. So this is an adaptation of the engineering lifecycle that we at BlockScience adhere to. We usually go from initial stages with ideation and conceptualization all the way through requirements and design, implementation, and then towards the end for operations and maintenance. At the bottom, you can see some of the tools and research that we're building, all open source, to facilitate these projects. Among them, you will, for example, see operational digital twins, which we're building in CATCAT. CATCAT will probably be referenced a couple of times. It's a simulation framework that we've open sourced as well. What is important for us is that we're usually trying very hard to keep stakeholders in the loop, really build context-appropriate models, and use as much as possible ethical engineering standards to build new mechanisms, but also overall new systems. And now, thanks. Next, please. I think you can click once. This should appear. Yes. I wanted to show this little graphic to explain how we would usually target such a project, because in the beginning, we fielded a team of researchers from social sciences, also economics, but various technological areas as well. And in the beginning, a rather large team really went through different phases of uncovering requirements, uncovering context, finding out what is important and what isn't important to the mechanism that we're working on. But then over time, this team is shifting logically. So once we came, for example, to a reporting and monitoring phase, we now added Rohan, for example, who was helping on building the models and building the reporting pipeline, while in later stages, we might once again adapt these teams. Next, please. Here, I just want to put this up. We're going to share the slides after. I think these are 3 articles that we wrote about the whole story and how we got to Neural Quorum Governance, and I'll give a bit of a view of that now as well. Next, please. We can skip that as well. Next, thank you. So initially, all of our work usually starts with really mapping out what we're looking at. Who is involved here? Who is affected? What is the current process? What works well currently, and where should the future go? From there, we are then usually uncovering requirements. What must be true? What should be true? What do we want to be true in an ideal world? And some things became clear rather quickly, such as this should have long-term value to the ecosystem. We want this to be a notional fair or good system. It should be modular and flexible so you can adapt over time, but also scalable to onboard potentially many more users over time. And then obviously some of the desirables were that the community should eventually co-own and cooperate these mechanisms, which for us means limited complexity, but then also similarities to established concepts and creating something innovative rather than just porting a mechanism that was built elsewhere and might contextually not fit very well. Next, please. From this, we later on were able to also describe this wish list. So here you can see some of the main attributes that we want from this mechanism and that we're building our design on. So effective and impactful, fair and equitable, scalable and streamlined, transparent but also private. There's always a balance here, flexible and modular, and innovative and relevant. Now, the important part here is that describing things as scalable usually doesn't mean much. As many of you will know in the crypto scene, one of the most vocalized attributes that everybody wants is decentralization. But you have to get to the bottom of what that really means. So over time, we were able to get more concrete on these things and really find mechanisms that are suitable to fulfill our wish list and our requirements and desirables. Next, please. One of the things that we uncovered while mapping was essentially a landscape of voting mechanisms. And here you will see one person, one vote, or one identity, one vote, various delegation mechanisms, other prior BlockScience research, such as conviction voting, where you time weight the token amount as well, but then also various attributes such as privacy through homomorphic encryption or other CK-related technologies, et cetera, et cetera. Now, we didn't want to port these, but we wanted to build a system where contextually you could fit these in. And that's why we came up with this neural governance, where different neurons can be strung together, aggregated in different ways to really build something that represents the community and over time allows them to adapt it as they see fit. Next, please. Now here we can see one of the earlier design sketches as well. What I want to highlight here is that there are different ways that this whole system could have gone, and it's always a bit of a balance of what do we want for a POC, what do we want to adapt next, and where should the journey go over a long time. So today we will also discuss in various ways how the system could be adapted, but for now, note that these early designs often include different sketches where we lay out what the system might look like. Next, please. And here is a bit of a larger graphic where we already incorporate what this might look like on a UI, so on a user interface, but also how these parts fit together and how people can either use the system or use it in ways that we might not imagine as being the primary usage in the beginning. I think all of these will be more visible once we share the slides as well. And with this, I think I am handing over. Artur, could you go to the next? Yes, Danilo.
I think he's still at backstage. Can we get him in, maybe?
Gabby, can you let Danilo in?
If not, then maybe we could skip to the next section, and then when he's in, we can come back here. That makes sense.
Let me just, Gabby,
Yeah.
can you let Danilo in? Okay.
Oh, perfect. Nice.
Sorry, say that one more time, Anka.
Can you let Danilo in? Like he's backstage.
Yeah.
Oh, perfect. Yeah. Hey, Danilo.
So, hi everyone. So let me present myself to the audience. So I'm Danilo, a research engineer at BlockScience, and my expertise is mostly on computational science, which is really about the part of using computation, simulations in order to do science. And of course, this involves a lot the part of scoping out how could we simulate a system, what are the modeling paradigms that we are going to use, and doing the simulation setup, analyzing the results. And what I'm going to present now is about taking from Jacob, taking from the requirements. I'm going to give a taste of the NQG specification and also just drop a few words about the model. It's a lot, so I hope, but yeah, next slide, please. Yeah, so this document here is a taste of, I mean, when we did conclude the ideation exercise for discovering how the voting mechanism could look like, we did create a very large requirements and specifications document. And requirements, we would say this mechanism should be scalable for this kind of growth, or this mechanism should uphold certain privacy requirements. And based on that, we did brainstorm several hypotheses, which, I mean, we all know that did end up converging to NQG. And yeah, this document here is really a taste of how that first report proposing NQG looked like. And next slide, please. And the actual specification of NQG, we all know Neural Quorum Governance equals Neural Governance plus Quorum Delegation. It's really two mechanisms that are mixed into one. The specification for them, for neural governance, I mean, it was actually the first module on the governance modules library. That was always the intent. And I'm providing a link there. I'm sure that all you that follow the governance modules library is aware. But on the specification, we would provide some general definitions. For example, what is meant by a vote? Or what are the inputs and outputs for that governance module? And along with the specification of what are the actions, what is the expected behavior, we would provide a more technical specification in terms of a pseudocode. We did discuss proposing a specification in terms of math, but because it's a module that's implemented in, I mean, it's a computational module anyway, it simply ends up specifying through code. And next slide, please. There is also the specification for quorum delegation, which, I mean, follows the same pattern, like what are the general definitions of quorum delegation? So yeah, so we would define here, for example, what would be a quorum, some terminology like what's the maximum, like, for example, what is meant by a candidate, what is meant by a quorum, what is also meant by the pool of candidates that could make up a quorum. And again, same pattern, we would have pseudocode as a specification. And I want to give a taste of the model, because after we did do those specifications in pseudocode, the next step was actually to, I mean, evaluate the actual output. We would create, let's say, we would create a synthetic data set that would represent the submissions and users at any point of time. And we would and our intent back then was to evaluate when we would run the algorithm on this input, would it generate the voting power that we would expect or the delegations that we would expect? So yeah, next slide, please. So there is a public GitHub repo that contains our first POC. It's actually the first full specification for Neural Quorum Governance. And I mean, the main components of that, you would have a part on which you would handily add new users. So the idea behind CAD-CAD modules and CAD-CAD simulations in general is that they are simulations for dynamical systems. The idea is that you have the notion of a state space. You have the notion that a system, the system of our interest has a state. The state can have something like 5 variables, 50 variables, 1,000 variables. It can have agents. It can have graphs. It can be like the variables can be really anything. And that's why sometimes we call it generalized dynamical systems rather than just dynamical systems. And KiCad is really a framework that allows you for creating those generalized dynamical systems models. And in this case, we would have a state, and I'm going to show afterwards, but we would have agents, the users. Each time that we would, the simulation occurs through discrete time steps. Each time we would add new users. Those new users, they would make decisions about voting on the submissions. The submissions would be a parameter. They would be fixed at the beginning. Those users would also make decisions about to whom to delegate, to whom to trust. So it's kind of, in a certain sense, if SCF was to run for 10 days, it was kind of like a simulator to see how things would evolve day after day, one way of putting it. And you can see some of the outputs that we would have from this POC demo, like some statistics about the vote, how the voting power would grow along the time. We can see that it's kind of like exponential-like because, and this is partially because of the nature of how the trust bonus was specified back then. It did change a bit. Now it's normalized, so it would not be that way. And I mean, we also would have views about the trust graph and delegation graph. And that was for the POC. And we did move forward, and the same model has been evolved, and it's being used now for the reports. And next slide, please. And right now, the model is more focused on allowing what we call counterfactual analysis. So the idea is we do have the results, but we want to see if the results hold against a simulation that implements exactly what we would expect to be the same logic, the same parameters. But we are also interested in what we call counterfactual questions. What would have happened if we did switch, rather than having Neural Quorum Governance, we throw quorum delegation away, and now only we have Neural Governance? Or maybe another way around. Actually, we throw away Neural Governance, we have one person, one vote, but we still have quorum delegation. What would be, how the results would look like? And the only way that it's possible to do that is really through simulation. So this is probably the most natural application. And this is very interesting because we could also simulate like what would happen if we add a new neuron. And the beauty of this thing is because we already have data across several rounds, we could even back test through the past. Like if someone would be to propose a new neuron, it would be completely feasible to us to look at the past rounds and say, those are the historical results. If we did introduce a neuron some rounds ago, the results would look like this. Of course, this presumes that we have the relevant data available for the neuron, which is not obvious. But just saying that the fact that we do have the simulation allows us to do this kind of analysis. Next slide, please. And yeah, I mean, I've been talking about the model in a somewhat abstract way, so it may seem a bit mysterious, like the thing simply simulates, but I'm going to try to give the details here. What is like? Well, first thing, it's a EBM. Like we have the voters as agents, and we also have several other objects inside that model. Like on that state space, we well, I'm going to move somewhat fast here because it's a lots of things today. But we would have things like the delegation graph. We would have what we call the action matrix and the decision matrix. There is also this very abstract notion of an oracle state, which is kind of like a container that carries out the relevant context for the neurons. And what I said, it allows us for doing those counterfactual analysis. And next slide, please. And yeah, I mean, if we were to specify the entire parameter space, state space, and the model structure, that's it. It's only those 3 prints. Of course, when you see the specification of the logic or how we specify the parameters of the state or the entire workflow, it becomes way bigger than that. Next slide, please. And yeah, and this is an example on how we configure neural governance in the CAD model. Like on the left, we would specify, we would layer together all the relevant neurons. We would specify what is the aggregator being used on any layer. And we also would create this sequence of layers through the default NG layers. And on the right print screen, I just put a print of the trust score neuron, just for showing how it's actually implemented on simulation. And next slide, please. And yeah, that's it. I mean, those are the 3 links that I can provide for you to learn more about the simulations and get acquainted with the details. We have the governance modules library that have specification simulations. We have the original POC. And there is also the current public implementation where the actual code that we are using for produce those counterfactuals are available in a public fashion. And yeah, I think that's it. And thanks for the attention. So yeah.
Hey, Arthur,
right.
do you want to take the next session? Yeah.
All right, thank you, Danilo. So I'll just go over the implementation. So hi, I'm Artur Michałek from Software Mansion in Kraków, Poland. We've been working with Stellar on implementing the NQG for on the Stellar ecosystem. So on Soroban, which is Stellar's native smart contract platform, as Anki mentioned. So I'll just switch quickly to my browser and I share some code. So actually the contracts for the code for the governance is mostly open source right now, and we'll share the link to the repo after the presentation. So the way we structured it is we had to implement NQG on the blockchain. We experienced some couple performance problems with the network, because turns out that NQG or some parts of it are actually quite resource intensive. So especially the part where we have a trust neuron, which just computes a lot of things. So the way we implemented NQG on Stellar is we did a kind of a hybrid approach. So we have contracts, which is actually the thing that is on chain, but we are also computing a bunch of things off chain, which is neurons, and I'll go to that in a second. And we are basically combining this data from off chain on chain to kind of offload the neutral network, and also to prevent user privacy, but I'll mention that in a second. So the way we're structured it is, if you go to neurons and neurons, we have the code for each neuron. It's quite similar to the simulations that Danilo was showing just in a second, but in high-level overview, basically what each neuron does, each code of the neuron does, is just computes a map of string to F64, which is a map between a user's public key and their scores. So we have this files for each neuron, and from these maps, we just get a JSON Swift user scores for each neuron, and then we upload that to the contract. So that's the one part we are currently computing off-chain. And also, we had another concern that kind of appeared while we were implementing this. So the currently voting works in a way that the user interface uses Discord usernames of SCF users. So when you select your delegates, for example, you select them by their Discord usernames. But the contract is using public keys, obviously. So if we just uploaded that directly, we would kind of leak the connection between the username and public keys. So as a kind of a temporary solution, before we move entirely to public keys, we also implemented the quorum resolving offline, which is just here. I won't go through that, but basically it also produces a map between like user, public key, and their votes for each submission. So that's a thing that is done off chain. We get a bunch of files, and then we have contracts. So this is also a bunch of things, but maybe I'll go to the more important parts. So first of all, we have just a try, because it's easier to understand. Here we have a governance implementation, and the way it works is, for each neuron, you can just you can configure a neuron and get the details about them. But eventually, like what you can do is that for each neuron, we upload their specific results from the file we got from here And we have just our internal scripts that handle the data uploading. And also, if we go to the implementation of the voting part, we also, for each submission, we upload their specific votes, and then we can tally the votes on chain. And what it does, it gives us a nice balance between like a resource usage and also things being on chain. So because we upload each intermediate result to the network, and because we are doing tallying on chain, there is a still traceable history that is permanently written to the blockchain, to the Stellar blockchain, which the users can trace. And we aren't like hitting the performance limits with the current approach. And the eventual plan is obviously to move more parts to chain as it becomes available. But for now, that's the current implementation. Maybe I'll just shout out one thing. So if anybody wants to see like the whole voting flow, we also make the link to that. But here's a test that just kind of show how the whole voting goes. But since we are kind of over time already, maybe I'll just end here and hand it off to Rohan.
Yeah, hey Arthur, thanks for that section. I mean, honestly, there were some things that even I didn't know, and I learned a lot from this. But yeah, if we can move to the next slide, maybe I can. Yeah. So yeah, my role was primarily around building reports and analyzing the results of the voting rounds that happened. I feel like it was important for us to know that, you make a system, like you go through the process of coming up with the idea, as Anki described, or like then we design the process as Jacob described. We go to Danilo's work where we actually come up with the digital twin, or like we actually build systems that actually where we can actually kind of like analyze and study the system before we actually put it on practice. But the second you actually put it out there and people start interacting with it, you start realizing that things don't work the way exactly you were supposed that you thought of. And that is when I think reporting and analysis comes in handy, where you have to constantly sense make as to where you are, and maybe retune the parameters or reevaluate the assumptions you'd made. And maybe if we can go to the next slide. So the way we went about this process is we broke the reporting into two different sections, which was like we have a automated report, which over the rounds that we put it together through a Python script, which basically just builds out these reports for us, where we understand how every neuron is interacting with or how they're computing the results and what they're computing to for every single project through every single user, and also how the quorum delegation results go. So maybe this is a showcase of how, I mean, in some sense, we are seeing how different neurons are being aggregated into the values that they're adding to the total sum at the end. And if you could go to the next slide, this is the automated part of the section where you can these scripts that we've built can automatically generate these kind of reports, where we can then put onto Google Slides and share it with people. You're seeing basically how people without any privacy, while having privacy concerns in mind, we are showcasing how what people delegated to and how those results actually ended up collapsing into whether yes, no, or an abstain as a result. So we can see the quorum results on the side, where basically how people delegate their votes to certain users, and how those, based on the users, other voters, how they voted, you actually aggregate them into the results that you see on the right. So these reports are automated. Once we get these reports out, generally, if we can move to the next slide, we actually end up in a section where we deep dive into the process of actually understanding the insights that we can get from the reporting process itself, whether there is anything that we need to contextualize the results, because you can get all these numbers through every round, but to understand whether those numbers are more or less, or whether they need to be tuned or not tuned, these are things that Danilo, Jacob, and me would sit through post the automated reports and go through the data ourselves. Here is where like the CAD process really comes in handy, because you can actually do the counterfactual simulations, as Danilo pointed out, where you can say that, okay, let's remove the trust bonus. Let's remove the maybe voting history and see what would have happened. And whether any individual neuron is overemphasizing their say on the vote, or whether we are actually doing what the community expected the mechanism to do. Because the thing about like quantifying these unquantifiable metrics is that whenever we put it into numbers, we have to actually understand whether it actually meets the criteria that is required by the community. And a lot of community feedback in these kind of processes is required to understand, okay, we have a mechanism, we have people voting, does it actually end up doing what we want to do? And the entire research and the process of analysis and reporting came down to us constantly figuring out how to tune these parameters to get what we want. Generally, the insights that came out of it was recalibrating the neurons. We had ideation for neurons because we understood that, hey, maybe the trust bonus actually doesn't capture what we really want it to. And then maybe we need another kind of modular input into the system itself. Or tuning the delegation thresholds, because very often we were seeing that the delegation results were kind of going towards abstain, and maybe Anki will point towards that soon. So yeah, these are the things that we kind of picked up through our process of reporting over the rounds. And majorly it was, I feel like it should be a continuous process that we continue to steer these technologies towards what the community actually wants. And having this modular system of neural quorum governance can actually help us input new things that communities care about, take them out, figure out how to tune them. And luckily, if you can get to the, if you can share the link somehow, we will find a way to, you can actually see the open source reporting and the open source framework that we've built to do this. Also, maybe we can actually, we've already crossed a bunch of times, so maybe I can pass this on to Anki. We can start off the roundtable fireside chat, and I would like to maybe start with the question okay, we've gone through this whole process. We've gone through this whole process of reporting and of design and ideation and stuff like that. What was the key insights for you? What was the thing that actually you came off with at the end of it once we actually put it out in practice?
Yeah, I guess should we stop sharing the screen? I did actually was able to share a few links in the YouTube chat, so definitely check that out. All right, yeah. So I mean, in terms of the whole process has been really interesting, right? And I think a few of the key points was that with quorum delegation, especially when we entered and allowed a non-voting kind of a non-active voters such as Pathfinder. So these roles can be automatically claimed by proving your expertise, and then we're actually able to start to delegate. And so that actually doubled our voter count, so which was really exciting, and also allowed people to get more involved while not necessarily having the right role yet. So I think it's definitely in terms of Neural Quorum Governance, the way it can be designed is that you have role specific abilities, and so that you can actually allow a much more inclusive space for governance and for contributing to decision making. I would also say that it's quite interesting if you look at I pasted the link here to the Stellar Community Fund handbook, where we list all of the different reports that BlockScience has published. And if you can see here, actually the results from one vote, I guess one person, one vote, and Neural Quorum Governance, they don't differ as much in if you look at the clear yeses or the clear no's. I think that's pretty similar across the board. What you can see is that there are some alternative options offered by NQG when it comes to those maybes or gray area decisions, which might allude to actually being providing a better alternative or a better I guess consensus when it comes to certain decisions like these, when there's not a clear consensus. That again, more research needs to happen in order to actually prove this statement. But so far, the community has consistently chosen the NQG or preferred the NQG outcome, which slightly different from one person, one vote, over the one person, one vote outcome. So yeah, it's been kind of like interesting to see like how that process went. I would also say like, I guess maybe going into some of the challenges, right, that we had. I mean, Arthur already alluded to it, but like balancing privacy, like transparency and computational efficiency has not been easy with the current features of Sorbonne, but it's definitely like allowed us to think more creatively. Currently, like the implementation of NQG and SDF employs a hybrid computational module, which means that the contract aggregates results from each neuron to a certain final voting power for submissions, with computations actually performed off-chain and result uploaded to the contract by our admin, which is Arthur. So this actually was the only kind of preferred solution to balance these intense kind of computational demands of NQG's design with some level of efficiency to ensure voter privacy while having some form of known reputation. And so like until obviously like a compatible layer 2 or ZK or rollup solutions are available on Sorbonne, the current implementation is unable to provide a complete on-chain verifiable proof of computation, which prompted us so the choice to like either prioritize voter and delegate anonymity or the verifiability of results. And so heeding the community feedback, obviously we chose to safeguard voter anonymity. And consequently, like we only uploaded normalized votes and final neuron results for on-chain tallying. So this actually prevented potential leakage between like Discord usernames, which is the identifiable part of the voters, as well as the public keys that are used in the contract. And so this lack of full insight into voter activity led to a relatively low success rate of delegations, and mainly because there wasn't a guarantee that selected delegates were able to vote. We try to combat this by enhanced UI, displaying an aggregated activity score. And while it did actually improve delegate success rate, we weren't able to raise it above 60%. And this you can actually see in the reports. And so actually in the next version release of the Style Community Fund, like the award structure itself, which should be opening up again early September, we're improving the entire award structure by introducing category-specific quorum delegation, where members can actually select delegates for each project category, whether it's financial protocols or applications or infrastructure and services or developer tooling. This process will happen quarterly rather than every monthly round, allowing a bit more flexible participation, but it still like has the same features. So like the contract and kind of design itself won't change. So there's still like people are able to vote directly or are able to delegate, but the people who actually meet a minimum, I guess, like quorum of like, I guess, like the number of times they have been delegated to will actually like be in a special kind of like a panel to like also influence what the criteria of that category will be for the next quarter. So this actually like introduces also like as there's a nomination process, it's more likely that these delegates will be voting more actively rather than, I guess, like just having the role and not actually, you know, implicating, oh, I am available to delegate and vote actively next quarter. So that should hopefully like help and combat some of the systems. I also think that neural governance itself is quite complex. Because like it's like so awesome that you have all this customizability, right? But then what it does introduce is like a level of complexity. There are various neurons, each have their own mechanism for attribution of voting power, which can be layered and influence another as well. They can also change over time, which means that there's so many variables and parameters that can be changed. So which Rohan kind of alluded to, needs some like really heavy kind of analysis and like being very on point. It's like, oh, what's actually happening? I think quorum delegation itself is very interesting. Also in the sense that it's a little bit simpler in a way, and it can be like, I guess, like a lot more process can implement it. So I think definitely as people are looking at implementing this, which I would love to, like looking at the different kind of factors, like what is the simplicity, what is like how complex do you want to go? But yeah, those are some of my learnings.
Yeah, actually, I really loved the idea of like having specific groups like for technology because I do think that that's how people vote, right? Like I would look at a project and be like, hey, I don't really understand this aspect of the project, but I know that some people who will. So maybe these kinds of projects I'll delegate to these kinds of people. I'm curious, Danilo, if you when we did the counterfactual analyses, I was kind of curious if when we noted that the quorum delegations weren't changing the results too much, maybe there were one project that was going above rank here and there. Do you think there's any process through which we could probably increase the emphasis of quorum delegation? And do we even need to? Like, how do you know whether that's something that the community actually wants?
Yeah, so about the impact, so there is some ways of putting. So the first thing is, as Enki said, it was an observation that across most rounds, and is that usually, I mean, in terms of the relative distribution, the results of NKG is not, let's say, orders of magnitude away from one person, one vote. I think that what NG and KD introduces is actually the capacity to disambiguate on edge cases, on projects that are far from consensus. Maybe another way of putting is, we have this distribution which we have projects on which everyone votes yes. There is also the projects that everyone votes no. And all the complexity in the world, it's not going to help to, change the results for those that receive all yes or all no. I think that the place where NKG is more important is when you have something like half of the votes being yes and half no, or maybe 2/3. And on those cases, who's voting matters a lot. Like, contest matters a lot. And there is an important thing, which is, it's always, how do we collapse the results? Because, NKG allows you to set a number, but usually we are looking at the ranking. And in terms of the ranking, the fact is, turning quorum delegation off can't change the ranking. And depending what's your threshold in order to approve or not approve, it could be the difference between two projects. Choosing two projects over other two projects. Exactly because of those cases on the middle, like the middle ranking projects.
Yeah, that's super interesting, because I think during the analysis too, we had these constant discussions where, how do we tune these parameters to make sure that the abstained results go down? But that's a process that I think every community will have to go through whenever this mechanism is being applied. Because again, it comes down to what they want, right? There's no standardized solutions for every case. Jacob, I would be curious if, like, from the context of GML itself, right? Like, we are trying to build this governance module library. We are trying to invite people to come in and contribute with us. What is the, I guess you can allude or like at least bring up the concepts of like how we templatize the idea from NQG into something that we can do for further governance modules. Maybe you can discuss how that helps us with governance modules, because I don't see any comments as such.
Absolutely. And
but yeah, feel free. People feel free to ask us questions on the comment section. Yeah.
Absolutely. So when I first in the talk alluded to how we go through this engineering lifecycle, this is something that we at BlockScience adhere to for almost every project. So we go through different stages of doing research and different stages of testing and validating our ideas. Now, for both NQG and for the GML, Governance Modules Library in general, community contributions, community understandings are super important. Governance mechanisms live off of context. They only thrive if the stakeholders are actually wanting to use them, if they feel represented, if the mechanism feels legible. So what is really important for us is that we initially bring in the approach that we would usually tackle this with. So this is also why in GML you will see a backlog approach where we move through different stages from a rough general idea to something that is much more research to something that might even be in development. Now, initially, we held this process quite close to how we would tackle it as an engineering process, but we definitely and explicitly say so want to adapt this process over time, depending on how the community feels these stages are useful and where they can contribute. Now, it is important for me that this stage process does not only include code. So obviously we manage it through a GitHub repo, but we explicitly make at several stages place for anybody to contribute in text and in any form that they feel useful. I'm personally also an economist, so for me, research is often heavily text-based as well. Now, for how the community can feel better represented here is, in my opinion, really to contribute, to be active in the discussions, and to shape how this research is being done. We don't want to impose these stages. We don't want to impose how we do research, but only when feedback comes and an active discussion happens, both NQG can be adapted to what the community feels and wants, and GML can be actively contributed both to NQG, but also to other governance applications, landscape and ecosystem, where anybody can represent their ideas and get input from others as well.
Yeah, thanks. I think that I kind of like very comfortably leads into this. We've started like these discussions on a GitHub repository, like where we can feel free. Like, I mean, I guess we can share the link on the chat if we can. Then here's the link. But basically, I've started a discussion where I just want people to, whoever's watching, like just come in, drop in a hi, drop in a introduction if you want. I feel like the more people that come in and we can have these discussions as to your maybe experience with NQG and what you think it lacked or you would have wanted more. Maybe it could just be an idea for a new governance project, maybe new modules that you want to add to the governance module library, because at the end of the day, again, as Jacob pointed, like it's the community feedback that's probably the most important in this process, because only then we know whether we are steering the technologies into the right direction. And yeah, so like there's a post where on the comment section where you can just join in, say a hi. It's a discussion. Feel free to like add issues. Like any kind of contribution is not small. Like just start being a part of the community. It'll really help us get back the feedback that's desperately needed, I guess, in this space. Also, Anki, if you have any, like, what are the new things that we are going through in this direction? Maybe if you want to add some points on that aspect.
Yeah, for sure. I have shared my screen. Let's see, maybe Gab, if you can put it up. Slideshow. So yeah, so basically like the future features kind of of the like pilot implementation of Stellar Community Fund will include like category specific quorum delegation, dynamic voting, power attribution based on logical curve rather than linear. So this helps us actually like have a more like holistic kind of overview of like gaining and losing voting power based on also like how people learn, how people like trust, how people lose trust, which is something that we're trying to mimic. Then also like I guess like as I mentioned, like phased voting, which we'll implement. We're also experimenting with more influential kind of neuron weighting and additional neurons such as expertise, like a organization called Trustful, like Blockful is building Trustful, which is also kind of like implementing an expertise neuron in Neural Quorum Governance. So there's many different ways to kind of collaborate here, as well as once Sorban has the ZK kind of like or like features, we'll add additional like verifiability and transparency while maintaining voter privacy. So I'm very excited for that as well. Definitely encouraging like contributions to the open source repos. I shared a few in the YouTube kind of chat here, and also like, you can find it if you navigate to the Community Fund website, like communityfund.stellar.org/handbook. You can go to the governance, like the Neural Quorum Governance section, and you can also find kind of updates of what we've been building, all the links to the different reports, links to the GitHub, and anything. And so very soon, like in the next few weeks or so, we'll be reaching out to the community and to anyone who's interested into actually contributing to some of the issues that we have here. So really supporting the feature development. We'll also work with OnlyDust to incentivize kind of these contributions, so that it's not just like for your own kind of like benefit, but also like actually having some kind of like fun rewards to like really incentivize and like, encourage participation on these two repos. And so the repo for like NQG's like implementation in SCF, as well as the one of the governance models library. I believe that BlockScience was interested in participating in that as well. So yeah, I mean, also like we're like really incentivizing different implementations of like also different forms of different types of communities or on different blockchain chains, even in technologies for Neural Quorum Governance, right? It's a framework, it's not a mechanism. So there's many different ways where you can actually like, either implement like one of the modules that are in the governance models library, or like both, or you do Neural Quorum Governance, or you do a whole different set altogether. I think like any type of like form of liquid democracy that hasn't really been like explored that much in the blockchain space also, but actually blockchain could be a really great technology to implement such a system. So definitely encourage experimentation there. And also like any research of like other reputation-based liquid democracy type of system is always welcome. So yeah, I'm really excited to get people involved. There's also like a Discord. So if you go to like, let me see, I can go to my next slide.
I don't think I can see the slides, can I?
Oh, okay. Yeah,
Yeah.
maybe. Anyway, I'll paste them here, but yeah, I'll paste the link. So basically, like we have like the kind of NQG. So let me paste that real quick in the YouTube. Here we go. And then I also like posted the governance model library above. So they're all in the YouTube chat right now. All right, that's it from my end. Rohan, do you want to finish it off?
All right, yeah, thank you so much. Yeah, I mean, we have crossed the hour, but yeah, I just want to leave it off with saying that, hey, thanks for joining the call. Thanks for watching this. I think in general, it's been really lovely and refreshing to work with people like and a team and the Stellar community in general, but we are focused on like fairness, privacy, growth. I mean, throughout the entire process of discussing NQG and GML, I think there was a constant emphasis on like sustainability, on fairness, privacy constantly. Like there's just discussions happening in this space. I really appreciate that this community is coming together and again building something as important as governance, which basically shapes the future of technology that we are building here. So it's really nice to have a team like this. Anyone who wants to be a part of the community, feel free to drop in a chat like on the governance module library. Again, just saying a hi helps. We'll start the discussion from there. But yeah, any ideas that you have, feel free to drop in. We'll start. We can start discussing and probably add those in the modules themselves. Yeah, thanks for joining the call. Thanks, Jacob, Danilo, Ajo, Anki, everyone, and the streaming. I guess Stellar Development Foundation for like streaming this too. Yeah, thank you.